Half a day. In this video, we'll cover operations and variables. We're going to focus on algebraic expressions and specifically how to evaluate them, how to use the distributive rule with algebraic expressions, and lastly, how to simplify them. First of all, an algebraic expression is an expression that includes variables, coefficients, numbers, and operations between them. An example is 3x squared plus 5x minus 1. Anything with different variables or a variable and an operation is considered a variable expression. In order to evaluate an algebraic expression, we have to follow these two steps. The first would be to substitute each variable by its given value, and we put these in parentheses. The second would be to just evaluate following the order of operations, and we always want to keep in mind PEMDAS. Okay, I think the easiest way is to do it by example. So we see here 3x minus 5y when x is equal to 10 and y is equal to 4. So the first thing I'm going to do is substitute in the values of the variables. So the value is a number that it's equal to. So the value of my variable x is 10. So instead of x, I'm going to put 10 in parentheses. Minus 5 times y, which is 4. And whenever you're substituting in these values, keep in mind that if there's a coefficient or if there's a number in front of your variable, it's going to be multiplied together. It's not 310, it's 3 times 10. So now we're going to follow the order of operations. We're going to multiply before we subtract. So we have 30 minus 20. From there, we'll subtract. 30 minus 20 is positive 10. For letter B, first step would be to substitute them in. A is negative 1, so we have 2 times negative 1 minus 3 over 10 times negative 2. And now we'll evaluate using PEMDAS. So we always want to see whatever's in grouping symbols first. Notice that there's no operations being done whenever you input these variables into the thing. So even though negative 1 is inside of parentheses, there's no operations working on it, so I don't need to do anything inside there. However, this fraction symbol, this bar, actually acts as a grouping symbol, so that groups it between the top and the bottom. So I'm going to evaluate the top and the bottom separately and then divide at the end. So 2 times negative 1 minus 3, that'll be negative 2 minus 3 over 10 times negative 2 is going to be negative 20. From here, I'll still evaluate that top one first before I divide. Negative 2 minus 3 is going to become negative 5. For me, I don't even think of it as minus. I just think, okay, negative 2 plus negative 3 is negative 5. Then we have negative 20 in the denominator. I'll simplify this fraction by dividing both sides by 5. And then also negative divided by a negative, I know is going to be positive. So 5 divided by 5 is 1. 20 divided by 5 is 4. So 1 over 4 is our answer. For letter C, we're going to just plug them in. Notice that there's B. B occurs here twice, but I'll just be plugging in negative 7 twice. Negative 7 minus negative 7 squared minus 4 times A, which is 3, times C, which is 2. So again, we have our grouping symbol. That radical is a grouping symbol in itself. So we'll work on the inside of that. Of course, we'll have to do that perfect square. So negative 7 times negative 7 is going to be 49. And then 4 times 3 times 2 is 12 times 2 is 24. So minus 24. We're still evaluating inside this radical. 49 minus 24 is 25. Okay. Radical again, I want to figure that one out. So The square root of 25, we know it's just 5, so we have -7 minus 5. From here, I'm just combining -7 and -5, which is going to be -12. Moving on to the distributive rule, we've touched on this before. A times B plus C in parentheses is equal to AB times AC. You're just distributing what's on the outside to everything inside the parentheses. And this works if you have B plus C plus D in the inside too. It'll still be distributed to everything within the parentheses. We're going to be using this rule to expand each of these algebraic expressions. So for letter A, we have 2 times 3 plus x. I'll just distribute that 2 to 3. So we have 2 times 3 plus 2 times x, 2x. For letter B, -3 now times x plus y. So now we'll distribute this -3 to x. -3 times x is -3x. -3 times y is -3y. Notice that for this one, it became a minus. For this one at the top, since it's positive, it's plus. This one's minus. If you do it the way that shows every single step, it would look like this. So it'll be -3 times x plus -3 times y. And then from there, it'll simplify to -3x minus 3y. You can jump straight to this one. That's perfectly fine. For letter C, we have something that looks a little bit different. -a plus b within parentheses. For this one, whenever you have a minus sign with no number attached to it, it's understood to be 1. So I'm just going to say, okay, this is a 1 right here. So I'm just distributing this. -1 times a is just -a. -1 times b is -b. And this is the expanded version. Ready? You don't need to do anything else. For letter D, we have a distribution with that extra 5 at the end. So 5 minus 2 times 2x plus 3. So since this -2 is attached to the 2x plus 3, I'm going to distribute that -2 and then just leave the 5 at the very front. So this is what I'm distributing. Let me actually highlight this. I'm distributing this -2 to both of these. So that 5 stays at the side. -2 times 2x, -4x. -2 times 3 becomes -6. And from here, I want to combine these terms, these 5 and 6. There's no variable, so I want to combine them. So we're going to have -4. And then 5 plus -6 is going to be -1. -4x minus 1. And lastly, we have simplifying algebraic expressions. So to simplify, we're going to be combining like terms using addition or subtraction. And like terms are terms that have the same variable to the same degree. So when I think about this, I'd say, okay, 3x and -5x are like terms. 4a squared and a squared are like terms. Same variable, so same letter, to the same exponent. We'll add or subtract the numerical coefficients or the numbers in front of our variables of like terms to combine them. We have a few examples here. 12a minus 7b minus 9a plus 4b. So I'm going to combine whatever has the same variable to the same degree. So we have 12a, -9a, then we have -7b, +4b. And I'll just combine them by adding their coefficients. So 12a plus -9a is going to be 3a. -7b plus 4b is actually going to be -3b. Negative 7 plus 4 is negative 3. For letter B, I'll do the same. We have an x squared, so that's actually, there's no other x squared, so it's on its own. We also have negative 2x and negative 4x, and then 5 and 6. It also works for numbers. If there's no variable attached, then those are like terms also. So 5 and 6, since they're just constants or numbers without variables, then they're like terms. So we have this 3x squared. Typically, you want to put it in order from the highest degree or the highest exponent to just the regular numbers on the end. So highest to lowest. Negative 2x plus negative 4x is negative 6x. And then 5 plus 6 is 11. And this is the simplified form. Our last few examples, we have for letter C, we're combining our distributive properties. So this minus 2x plus 5, what I'm going to do is distribute that negative sign. And we know that's going to be just distributing negative 1. So I'm copying the same first one, the same way it appears. So 3x squared plus 5x minus 1. Then I'm going to distribute that negative sign. So negative 1 times 2x is negative 2x. Negative 1 times 5 is negative 5. Notice that all it does is change the sign of whatever's following it. From here, I'll combine like terms. If you want, you can match them again. So we have 3x squared. There's no other x squareds. We have x's, 5x, and negative 2x. And then for the numbers, we have negative 1 and negative 5. Now we'll combine them. 3x squared. 5x plus negative 2x. 5 plus negative 2 is positive 3. So plus 3x, make sure you do have that plus sign in between. Or a minus sign whenever it's negative. Negative 1 plus negative 5 is negative 6 minus 6. For letter D, so now we're using again our order of operations too, as well as distribution. So we're going to be evaluating what's inside this bracket first. So I'm just copying what's on the outside. 9 minus. Okay, I know I'm going to have to distribute this negative sign. So we're working in the inside first. So a minus 3, I'm copying again. Negative 2a. Negative 4, it's changing the signs of those. I'll combine like terms within that. We have an a and a negative 2a. We have a negative 3 and a negative 4. Again, I'm just copying whatever's on the outside. A plus negative 2a is negative a. Negative 3 plus negative 4 is negative 7. Okay, and again, brackets and parentheses work exactly the same way, so we're actually going to have to distribute one more time. So we're distributing this negative sign again to whatever's inside that. So we have 9. Negative 1 times negative a is going to be positive a. Negative 7 is positive 7. Combining like terms, the 7 and 9 are like terms. So this is going to be equal to a plus 16. Let me box these answers. There's quite a bit on this page. And for our last example here, we have this sentence. So subtract 4x minus 3 from 2x squared plus 10x plus 4. For this one, you always have to be careful. When it says subtract something from something else, this is going to be in the front. That 2x squared plus 10x plus 4 will be in the front, and you're subtracting something from it. So whatever you're subtracting should be at the end. So we have 2x squared plus 10x plus 4. We're subtracting 4x minus 3 from that. Okay. And then we follow the same rules. Once we set it up, it's easy. So we have to distribute that negative sign. So we have negative 4x plus 3. This one stay the same, 2x squared plus 10x plus 4. Identify your like terms and then combine them. Of course, you're not expected to carry around markers or highlighters of different colors for you to do this, but I'm just doing it just so, it makes it a little bit easier to find our like terms. 2x squared, 10x plus negative 4x is going to be 6x. 4 plus 3, 7. And that is it for this video. A fairly short one. I hope you learned something. Thanks for watching. Have a great day.